Alright, so happy Monday. What you're looking at is something I've been kind of screwing with over the last, on and off, I'd say over the last few months, but not in any real serious capacity. One of the things that's made the modern world that we live in pretty cool is that there's a lot of people out there working on individual little projects, and then they'll share code with you. And this is one of the neat things that the Arduino platform has brought to all of us, is this kind of open-minded sharing aspect. So what's neat about this is if I have a project I'm working on, I can come up with an idea of what I want something to do, and I can go out on the internet and see if somebody has built something similar. Maybe something that's close enough that I don't have to re-engineer everything to fit my needs. And this is a good example of that. The code that you're looking at came from a guy's website, and what he had done is he had built basically a VFO, a variable frequency oscillator, using one of these cheap little DSP board or DDS boards from eBay, and built a complete VFO around it, complete with limits and whatever else. And I've taken quite a few liberties with his code. The original libraries called for a liquid crystal display. This is going to be housed in a 1U box, so I needed something that was pretty small, and I happen to have some of these little vacuum fluorescent displays laying around, and they're SPI, and I found a library for that and ported the code over to this particular platform. And then along the way I also added some custom characters and changed the way the display was laid out, and even came up with some other kind of neat things that I thought would be useful. And so let me reload the code and see if it'll behave itself. There we go. So these are an example of some of the custom character sets that I made for it. And as you move the dial around, you'll see that this particular one is set up to tune in 5 kilohertz steps. So the first symbol on the left is the lock symbol, and what that's going to be used for is to tell you whether you have GPS lock or not for the GPS receiver frequency discipline. Next to that is an inverted S and T, and that's going to be used to indicate whether it's being received in stereo or whether the transmitter is in stereo or not. The white block with the exclamation point is a "hey stupid, you can't do that" explanation sort of symbol. Then obviously the frequency, and then on the right you have the antenna and the 3 signal bars, which will be used for signal receive purposes. Also down the road, the idea is that if this thing is integrated with any sort of telemetry, you could hook it up to the transmitter and it could monitor your output power and things like that, and the bar graph and the antenna would go away and display simply transmitter forward power. The whole goal is this started out as I have 4 pieces of equipment in my rack that I would like to condense into one. I have a GPS discipline 10 megahertz source, and I have a function generator that's being used to generate the carrier frequency from that 10 megahertz reference signal. This combines those into one, and in the end hopefully will also provide some level of remote control, monitoring, and also off-air monitor, and when the transmitter's not on the air, you can use it to verify channel conditions to see if there's anybody out there before you actually do flip the switch. A nice thing to do in the modern world of being a courteous operator. So anyway, this is just kind of an example of some of the things you can do with these little oscillators, and unfortunately, as much as a lot of people don't like it, we're all becoming more and more reliant on things that run on computer code. It's just kind of the way it is. On the bright side, though, it affords you the flexibility to use a lot of these new chips that otherwise you wouldn't have access to. So it gives you functionality that you otherwise wouldn't have, or would have to rely on other big pieces of equipment to do. So the name of the game is integration. We're figuring out how to take a bunch of different pieces, stick them together, and make them work cohesively to achieve our goals. That's what this is about.